that there's horizontal movement on that fault, and the horizontal movement is moved, you know, 30, 40 miles.
In St. Genevieve?
What?
The one in
In the St. Genevieve fault system, yeah. Yeah, the south side is geology that is totally absent on the north side. They're two different geologies.
Yeah.
And the only way you could do that is to move a piece of the earth from one part of the planet, 30, 40, because the nearest place that geology occurs kind of rationally is 50 miles from there,
yeah.
along the Mississippi River. It's and the weird aspect of it is, and this is how get myself thinking about this.
Yeah.
The weird aspect is that there's a very, very cherty limestone called the Bailey Formation, and it's way, way chertier than any other Missouri rock. I mean, it really is just super cherty.
Yeah.
And that chert hangs around. I mean, over on the around. What's it? I want to have that mention that because that's a good point. What's the name of that? It's a
Where's it
mound. It's in the Mississippi River.
Is it one of the islands?
No, it's got bedrock on both sides of the river, which is rare. I mean, and what's it? Oh shit! It's around St. Mary's. There's a name for it. I don't know if I ought to shave. Me too.
No, don't worry about it. Yeah.
What the hell is that? I'll show you.
Andy, look up what geological formations are.
It's an interesting part of the river.
In St. Mary's, Missouri.
It's right near St. Mary's.
Geological what?
Let me get a road map. I think it's on that.
Yeah, let him get a road map.
It's a place that steamboats had trouble getting through. There's this bedrock.
Not Chain of Rocks.
No, it's not. No, it's what's Neely's Landing. Oh shit! No, let me get a road map.
St. Mary's, Missouri.
There's Bailey Chert, and it's Bailey Chert and limestone, Bailey Formation, and it's probably 500 feet or 400 feet of rock. It's extremely cherty when it weathers. Now here's the thing that's weird. When the Bailey weathers, the chert is left behind as a residue. It's called residual chert.
Yeah.
And it's all over Missouri. I mean, but the Bailey Formation is the chertiest of the cherty Missouri rocks.
Yeah.
Really, really super cherty. And chert doesn't weather very. It sticks around. It's quartz.
Yeah, yeah.
It sticks around. On the south side, there's Bailey chert where it's weathered, and there's where the Bailey outcrops. There's lots of Bailey chert, and Bailey chert sticks around. It's flinty. It's hard. It's very, very resistant to weathering, and it sticks around for millions of years. On the north side of the fault at Ozora, there is absolutely not only no Bailey Formation, there's no Bailey chert.
Yeah.
But on the south side, there's a huge amount of it. And it's like two geologies. And the only way that you can take a formation like the Bailey, that's a continuous layer of rock covering a big area, is to take a little piece of that and move it somewhere else. And that does happen with plate tectonics. That's how plate tectonics really was discovered, that they found geology of one area
slid to another,
like glued to another, right? And that's what you have on the St. Genevieve fault. You have two geologies. On the south side, you have the geology of all this Silurian and Devonian rock. On the north side, you have none of that, none of it at all. You have the geology of Jefferson and St. Louis counties. And if there hasn't been movement of part of the earth, either part of Jefferson and our St. Louis counties moved in juxtaposition to the geology of around Grand Gulf area, or rather Grand Tower area along the Mississippi River, then there's no other way to explain it. And that means that part of Missouri had to have been moved 30, 40, 50 miles. And that's, in a continental geology, doesn't normally happen. And
could it have gotten thrown there by an underground explosion, blew a plate out?
Now, there'd be
section?
fracturing, and there'd be, all kinds of tectonic evidence or something like that.
Yeah.
It's weird. It's really, other than explainable by some sort of horizontal thrusting, what is called a thrust fault, a very low angle thrust fault, where that thrusting took place for 30, 40, 50 miles. There's no way to explain that.
But there's nothing to source the pushing it there.
No, nothing that you can see. No.
So it's just out.
It's not mentioned. Geologists don't mention it because it can't be explained.
Yeah, that happens a lot. They don't want to, if you can't explain it, then they don't even want to approach it.
Ignore it.
Yeah.
Yeah.
But you should ask as many questions as you can, I would figure.
And I know of no explanation I've ever heard for it. And it's the geology is weird enough that the University of Chicago had a geology field camp down there in the 1920s.
Trying to figure out what was going on.
Well, using it to teach students to be really good field geologists.
Yeah.
Because it's
it would have
really
thrown
challenging field area. The area's heavily covered with vegetation. And there's pretty many outcrops, but it's not like out in the western United States where you have,
right there in
huge
the open,
outcrops that are real easy to figure out what's going on.
Yeah.
In Missouri, you have to do some sleuthing to figure out what's going on.
Yeah, you would. All right, I'm gonna stop it there.
Miracles or what have you. I mean, science ignores those, and art tries to explain them in some rational way. And I don't know if I presume the rational explanation of the Ozora area is that it's thrust fault.
Yeah.
But I've never actually heard that from in my geologic background. Which, and by the way, I have 3 degrees in geology. I have, including a PhD from Rolla. I have a pretty kind of tough and extensive geologic background.
Well, most of your viewers know that about you already. All right, I'm gonna stop it.